going to be an introduction to the x402-BCH protocol. This is a play on the x402 protocol developed by Coinbase. So what I'm going to cover in this video is I'm going to quickly recap how x402 works. I'm going to introduce the x402-BCH protocol and how it's slightly different and the subtle ways in which it's different. And then I'm going to give a demo for developers showing how to run the example implementation that I've created to demonstrate this. And this is all very similar to how the Coinbase X402 protocol is presented. So real quick to recap on X402, it was created by Coinbase. If you read through the specification, in fact, let me show you. Uh, if you're not familiar with this, x402.org is the main website to find out about that stuff. It's under the Coinbase GitHub group because they created this under a repository called x402. They have a specification directory, and right here, x402 specification is right there if you want to get the official specification. So their spec and their example implementation is highly optimized for the USDC stablecoin on the Base blockchain, which is a layer 2 on Ethereum, which they also create and operate. Uh, and so I've modified or I've made slight tweaks to their existing protocol to make it work with Bitcoin Cash, which is a layer 1 blockchain. And it's UTXO based rather than address based like Ethereum chains. So these are some of the subtle differences between the blockchains. Um, the thing to keep in mind with X402, again, just quickly recapping on the core principles here, is there's three main actors. There's clients, servers, and facilitators. And I've seen several copies of this image going around. This is like a quick way to explain how X402 works. So you can see the client, the server, and the facilitator at the top. These are the three actors, and then there's the blockchain. The client sends a call to the server to get a resource, and the server responds with an HTTP 402 error code saying payment required. Um, the client then has attaches a proof of payment to the API call. It makes the API call again, now with the proof of payment attached. The server passes that payment information to the facilitator. The facilitator's job is to have all the blockchain specific logic in there so that the server can just be a web server and it doesn't need to know anything about the blockchain. And that's also powerful because this is what allows one server to accept payments on multiple blockchains. So the facilitator gets this verify call. It verifies the signature and says, okay, it's good to go. And then at some point, the server calls the settle endpoint, and then the facilitator takes all these. You can have multiple verify calls, and so you're kind of accumulating a debit, and then the settle actually settles the transaction on chain by interacting with the USDC contract on the base blockchain, and it actually settles the payment. So this is how X402 works. Uh, there's also, so we've introduced these three actors, client, servers, and facilitators. And then there's two main libraries if you're a JavaScript developer like me or a TypeScript developer. They have this X402 Express library and this X402 Axios library. So the Axios library is for clients, and Axios is a library for making REST API calls. And so it's this library lets you take like what you're already doing. If you already have an app that say makes API calls and you just want to add this X402 support into your flow, you just add this library. It wraps Axios, and it automatically handles those X402 error codes by making a payment and then retrying the call. And so that's a really handy library. So that's for the clients. Similarly, X402 Express is a library for servers, And it's if your server is written using the Express framework in Node.js JavaScript, and it's middleware, and all it does is it intercepts the incoming call, checks to see if there's a payment. If it doesn't, it rejects the call with a 402 error, and if not, or if there is payment attached, it passes it along to the facilitator to get the okay that this is a legit payment, and then that middleware handles it off to whatever existing logic you would have. So in a similar way, if you already have a web app server written in Express, you can just add this middleware, and it's not a big change in your code. And that's what's nice about these libraries. So these same concepts all apply in BCH, or X402 BCH. So there's a few subtle differences. One, if going back to this flowchart in X402 BCH, uh, the client pays the server directly. They'll pass on the address to the client the first time, and it's the same thing as the normal X402 protocol. But the client will send a UTXO because Bitcoin Cash is a UTXO blockchain. It'll send a UTXO to the server. The facilitator in the Bitcoin Cash version of X402, uh, it maintains its own state. It uses level DB to track these UTXOs. And so the client, for instance, might send 50,000 Satoshis to the server for payment, even though each call might only cost 2,000 Satoshis. So then as they call, they just reference the same UTXO. The server passes that information to the facilitator, and the facilitator keeps track of how many times, how much they've debited against that original UTXO amount. So they start with 50,000. Every call that comes in decrements it by 2,000. Once they've used up that budget, then the the verify fails. The server passes the 402 error back to the client. The client makes a new UTXO, and the whole process starts over again. And so this cuts down on transaction fees, and it's very similar to how they're doing it on the base blockchain by reducing these on-chain transactions. But in this case, there's no need to call the settle endpoint. The server never needs to call the settle endpoint because it's already been settled. The UTXO gets paid directly, and then the facilitator is just sort of keeping a local ledger that it's letting the client debit. So it's kind of like a prepay scheme, except the client gets to decide how much they want to prepay. Uh, and that is determined by how much they trust the server and how much they want to save on transaction fees. So if it's low trust and they're transaction fee insensitive, they can send a small amount. If it's high trust and they're very transaction fee sensitive, they can send a large amount. And so the client can make that decision as to what the appropriate amount is to send the server and then debit against. So that's the main conceptual difference in the BCH version. Similar to, so if I go to the X402 BCH GitHub group, there are 3 repositories. Inside X402 BCH repository, you can read the specifications, and there's a copy of the original X402, and then there's a BCH specification for that. And then there are these examples for a client, facilitator, and a server, and which I will demo here in a minute. But also under this X402 BCH group, there are 2 other repositories. There is a Axios library and an Express middleware library. So these work just like the examples that Coinbase provides for the core X402 implementation. They're very similar. And so just to give you, let me just do the demo and then I'll come back to the code. I'm sure a lot of you want to see what's going on. So let's see, I'm going to clear this. This is my facilitator. This is my server. So I'm going to go to I'm going to run the base Sepolia testnet version of the implementation. So this is all code from Coinbase. And then I'll run the BCH uh, example And then that way we can compare them side by side. Just getting my code ready to run here. So I am running, this is going to be the server. It's going to be the facilitator. So real quick note on the code for the base example that I'm going to run first, running on x402 on the base Sepolia testnet. The code's coming from Chris Troutner, my GitHub repository, x402-prototype, and this O1 directory. The client and the server are just straight up copied from the x402 repository. The facilitator is coming from, I want to give credit if I can. Uh, Okay, well, it's coming from another example. This fork right here, uh, made by DeWatt 10, who had some great posts on X about that introduced me. But this is normally the facilitator is run by Coinbase if you're using Base. That way, it's just less infrastructure for people to run. He created a sovereign one so that you're not dependent on them as a third party. But this is still focused on the Base Sepolia network. So this is a fork of this that I forked and modified is what we're running for the facilitator. So little caveat there with the facilitator. Okay, so running the server. Again, this is on the base network. That's the facilitator. I'm going to run the server. Okay, so the server's running and the facilitator's running. Now, there's going to be a call from the server to the facilitator every time the client makes an API call. And so that's why I think it's important for the facilitator and the server to be in the same data center or like physically close to one another. So anyways, let's run the client example. So first, step one, it makes the call and expects to get a 402 error. So here is the server responding with a 402 error and an X payment header. And I want to draw your attention here to the scheme is exact. The network is base Sepolia, and they use max amount required 1,000, which I think is a tenth of a cent in USDC. Um, and so these are some of the main actual tweaks to the protocol itself that I had to make. So we changed the network from base Sepolia or base to BCH. We changed the scheme from exact to UTXO. And we renamed max amount required to min amount required. And this number is in Satoshis. And so I'll show that here in the other demo. But just to stick with the base Sepolia example for a minute, there's no output from the server because this is just handled by the middleware, but you can see some of the information that the facilitator is working through to verify the payment. And these JSON objects, they match the data in the actual X402 specification. So if you want to actually go down to the nitty gritty, this is how you tie all that together. Okay, so I showed where the code's coming from. I've run it. Now let's run the BCH version, and we'll see how it's slightly different. So I'm running the code that is in this x402-BCH repository. If you go here to the main repository and then go to examples, this is the code that I'm about to run. Okay, so run the server, run the facilitator, and now I'll run the client. So it goes through the same. Oh, I didn't really finish going through it. The first time Step one is expecting a 402 error code. Step two, it makes the same call but with payment attached, and so it successfully accesses the endpoint. I kind of skipped over that. So the BCH version is doing the exact same thing. Step one, it makes the call without the payment header, so it's expecting a 402 error code. It gets it. We can see that the scheme is UTXO, the network is BCH, the min amount required is 1,000 Satoshis. And so on the second try, it makes the call and it generates a UTXO by making a payment to the server's Bitcoin Cash address here, and it successfully gets it back. But if we take a look at what happened under the hood, the facilitator uh, gets the call. Let me see. Bear with me. Yeah, okay. The facilitator, we're in the BCH version, it gets the verify endpoint, which came from the server. Here's the payment payload. Here are the payment requirements. So the facilitator is just to make sure that this is the information it has. Is the payment valid? That's the question we're trying to answer. It calls the blockchain and pulls up the transaction information for that UTXO, and it makes sure that the V out is going to the address for the output is going to the server, and that the amount of Satoshis are equal or greater than. And in this case, they're greater, so it's valid and it passes that back. There's a third step in the BCH version where it calls the endpoint again, but instead of making a new payment, it's reusing the UTXO from the first payment. The first payment was 2,000 Satoshis, and the cost per access is 1,000 Satoshis. So it's able to use that same UTXO to call the server twice and pay for both calls. And then if I was to make a fourth call, the server would respond with a 402 error, and the client would have to make a payment again. And so that's pretty much the demo. I'm keeping it a high conceptual level. The code's here if you want to dig into it. Uh, Again, I want to point out these libraries for the Axios library and the Express library. They are available as NPM packages, and they include READMEs on how to use them. So if you already have an API server and you just want to add x402 payments, you can use that Express middleware, and your server's already written in Express. You can use that Express middleware to very easily plug in the support for that. Also, if you're a client and you want to call an x402 server, you can use that Axios middleware to easily plug in for that. Um, Coinbase makes these libraries available for other backend frameworks and other front end uh, libraries, like the fetch call, which is starting to become more ubiquitous for both front end and back end. If people, I created the GitHub group so that it can be easier for people to collaborate. So I am looking to collaborate with others. I would love to see some pull requests, open some issues, and let's start a discussion. I'd love to see this expand to other libraries and programming languages and just fill the needs, but I can only do so much. So I'm trying to just get the ball rolling, and I'm hoping that the community will run with this.